Trigonometric identities. A trigonometric identity is a relationship among the trigonometric functions. The most elementary are the following, which are immediate consequences of the definitions of the trigonometric functions. Equation 6, cosecant theta equals 1 over sine theta. Secant theta is 1 over cosine theta. Cotangent theta is 1 over tangent theta. Tangent theta is sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. For the next identity, we refer back to figure 7. The distance formula, or equivalently the Pythagorean theorem, tells us that x squared plus y squared equals r squared. Therefore, sine squared theta plus cosine squared theta equals y squared theta over r squared, equals y squared over r squared plus x squared over r squared equals x squared plus y squared over r squared equals r squared over r squared equals 1. We have therefore proved one of the most useful of all trigonometric identities. Equation 7, sine squared theta plus cosine squared theta equals 1. If we now divide both sides of equation 7 by cosine squared theta and use equation 6, we get equation 8. Tangent squared theta plus 1 equals secant squared theta. Similarly, if we divide both sides of equation 7 by sine squared theta, we get equation 9. 1 plus cotangent squared theta equals cosecant squared theta. The identities 10a, sine of negative theta equals negative sine theta. 10b, equation 10b, cosine of negative theta equals cosine theta. Redoing equation 10a, sine of negative theta equals negative sine theta. Again, 10b is cosine of negative theta equals cosine theta. Sidebar, odd functions and even functions are discussed in section 1.1. Back to the text. Show that sine is an odd function and cosine is an even function. They're easily proved by drawing a diagram showing theta and negative theta in a standard position. See exercise 39. Since the angles theta and theta plus 2 pi have the same terminal side, we have equation 11. Sine of theta minus 2 pi, sine of theta plus 2 pi equals sine theta, and cosine of theta plus 2 pi equals cosine theta. These identities show that the sine and cosine functions are periodic with period 2 pi. The remaining trigonometric identities are all consequences of two basic identities called the addition formulas. Equations 12a. Sine of x plus y equals sine x cosine y plus cosine x sine y. Equation 12b is cosine of x plus y equals cosine x cosine y minus sine x sine y. The proofs of these additional formulas are outlined in exercises 85, 86, and 87. By substituting negative y for y in equations 12a and 12b, and using equations 10a and 10b, we obtain the following subtraction formulas. 13a, sine of x minus y equals sine x cosine y minus cosine x sine y. Equation 13b, cosine of x minus y equals cosine x cosine y plus sine x sine y. Then by dividing the formulas in equations 12 or equations 13, we obtain the corresponding formulas for tangent of x plus or minus y. Equation 14a, tangent of x plus y equals tangent x plus tangent y over 1 minus tangent x tangent y. Equation b, tangent of x minus y equals tangent x minus tangent y over 1 plus tangent x tangent y. If we put y equals x in the addition formulas, equation 12, we get the double angle formulas. Equations 15a, sine 2x equals 2 sine x cosine x. Cosine 2x equals cosine squared x minus sine squared x. Then by using the identity sine squared x plus cosine squared x equals 1, we obtain the following alternate forms of the double angle formulas for cosine 2x. Equation 16a, cosine 2x equals 2 cosine squared x minus 1. Equation 16b, cosine 2x equals 1 minus 2 sine squared x. If we now solve these equations for cosine squared x and sine squared x, we get the following half angle formulas, which are useful in integral calculus. Equations 17a, cosine squared x equals 1 plus cosine of 2x over 2. Equations 17b, sine squared x equals 1 minus cosine 2x over 2. Finally, we state the product formulas, which can be deduced from equations 12 and 13. Equations 18a, sine x cosine y equals 1/2, open bracket, sine of x plus y plus sine of x minus y, close bracket. Equation 18b, cosine x cosine y equals 1/2, open bracket, cosine of x plus y plus cosine of x minus y, close bracket. Equation 18c, sine x sine y equals 1/2, open bracket, cosine of x minus y minus cosine of x plus y, close bracket. There are many other trigonometric identities, but those we have stated are the ones used most often in calculus. If you forget any of these identities, 13 through 18, remember that they can all be deduced from equations 12a and 12b.